Hey.
Hey, man. I guess the link worked if you're here.
It worked for me. I was trying to figure it out. Do you go to Creator Studio, you go live, then you go to events?
Yep.
Okay.
And then once you hit events, you click on the upper right-hand side, it's new live event. I had to do it a lot last semester.
Yeah.
And anyway. So anyway, we're here now.
Yep.
So Lexi, I know, was coming.
Hey guys.
There she is.
Oh, there she is. Okay.
Hey, I have a question.
Yes.
So I'm working on the preparation assignment right now, and I'm on like numbers 9 and 10. And have you guys already done the preparation assignment?
Of course.
Okay.
Yeah.
So I'm just wondering, because in the end of the question it says the T-score for 95% confidence interval, it gives us the T-score. Did I miss in the reading where it showed us how to solve for the T-score? Is it always going to give us what the T-score is?
No.
Yeah, we solve for the T-score.
Go back. Which question are you on? Sorry, I'm now caught up.
On part 2.
Part 2, which number?
9 and 10.
So I just I plugged it into that what is it called? The Excel file, the inference one.
Well, there is a formula to get the T-score. It's very similar to the one to get the Z-score.
Right.
It's the
Is that the T equals sample mean minus population mean over sample standard deviation divided by the square root of the number?
That's it.
Yep. That's it.
Okay.
Yeah, the only difference is the let's see, the standard deviation is the sample rather than the population. So it's S or whatever that is rather than sigma.
Okay. So in 9 and 10, when it says that the 95% confidence interval with the 14 degrees of freedom is 2.1448, I could have found that if I had just plugged everything into that equation.
Yep.
So where does the 14 degrees of freedom go into that equation?
It doesn't.
I
haven't figured out what the freedom means yet. It's n-1, but I think maybe it comes in later. I don't know what it does yet.
Yeah, I haven't figured it out. I'm with you. I don't get it either.
It's interesting at this point. That's it.
Okay.
It's obviously important because we keep bringing it up. Lots of the questions in the quiz were on that.
Yeah.
Has anybody else taken the quiz?
I've taken the group 11 or the group quiz. Yes.
Did you take the regular quiz?
I haven't taken the homework quiz yet.
Okay. Well, I might have to have somebody that has after they take it. And maybe we can just talk generally. Here, sorry, let me turn my music off.
And you guys work late.
Well, I'm on a graveyard shift this week, so.
Yeah.
I'm just going to get my homework done before I go.
So, in the quiz, it asks us to find the margin of error for a 95% confidence interval for the true mean return of the investor's portfolio. So it's you use the rates of return spreadsheet.
I think the margin of error formula is T times the S. I can't remember what that's called. It's the
The
sample
yeah,
divided by square root of n.
right.
That should give you the margin of error. Then that's what you add or subtract from the sample mean to get the interval.
Wait,
Am I right on that? Does that sound right?
Yeah, that's what I have written down, but I still didn't get the right answer.
You know, I've been using Excel just because I made too many errors on a calculator. I don't know. That'd help.
I've been doing it in Excel as well.
Yeah. I kept getting these big square root numbers and I couldn't get them back in the calculator right or something.
Yeah, I've used the calculator the whole time. But see, so maybe I'm supposed to plug the rates of return into the normal probability app, because it does give us that one on the. I don't know what the right answer is because I did two different ones and it didn't give me the right answer. So maybe it's it might be that, not the quantitative inference, the quantitative, there's another one.
You talking about the Excel sheets that are given from the class for the class?
the quantitative descriptive statistics?
Yep. That might be the one I have to plug it into. I'm trying it. Oh yeah, because that'll give us the mean, the standard deviation. Yeah.
It like solves it for you.
So just a heads up, I would use that one on the quiz, the homework quiz or whatever they call it in this one.
But can't you put it into the one for the T and get the mean and the standard deviation as well?
I don't know. I used that to try and find it, and I either plugged in the wrong answer or I don't know. I did something wrong because I got it wrong twice.
Yeah, that hurts.
Yeah. And then on that one, so let me see. So this is saying the mean is negative 1.107. I'm just going to round it for.
What number are you working on?
It's one of the homework or the quizzes in the so the individual quiz you take.
Oh, it's on the homework quiz?
Yeah.
Oh, I see.
So I'm just trying to talk through it with you guys because I struggled with it. So if I'm finding the margin of error, what is the t-score for a 95? Remember how we had in the last one, we had that.
Yeah, the t-score, you get that in the t-score applet. You put in the 0.95 in the top part, and then you look down where the z-score would be, but it's a t-score. And I think it's 1.96 for 95, isn't it?
That's when you know the mean.
Well, that's how you get the t-score if you know the probability. Or the
That's if you know
the level of whatever.
Right. Confidence level.
Yeah.
But this one, we don't know it.
Okay.
So I've got so many things open right now.
Same. Wait, so did you try plugging it into the t-distribution formula? Like with the population mean, or what is it? The sample mean minus the population mean divided by the sample standard deviation divided by the square root of n. Did you try doing that?
That's where I'm at.
Oh, I see.
Try and find it. I just don't know what that t value is. Because anyway, I was looking to see. We can go on and do the homework quiz, group quiz.
Well, you can get the t-score off of the quantitative inference procedures. If you put in the variables down the side, then you put the proper confidence level in, and then you put in what your null hypothesis is. Straight down from that, it'll give you the t-score.
Right, but that's not the one for your confidence level.
Well, you have to. Okay.
You know what I'm saying?
No.
To find the margin of error. I'm still trying to find the margin of error.
Okay.
And the T with the asterisk is the one, like in the last lesson, that showed that 1.96 and all of that.
No.
Am I making any sense, or am I completely gone crazy?
Well, maybe we should. Well, maybe we should go through the quiz, and maybe that'll answer some questions as we get there. Is this if the same one's in here?
Okay.
Go through the group quiz.
Yeah, maybe that's a good idea because it does. I mean, I didn't even have this link to the applet before the quiz. Like, I just opened it and got the link right now.
Okay. All right, let's go through it. This does record automatically, right? I don't have to do anything special.
I mean,
It says live in the top right corner.
Yeah. Because I think once we're done, then it.
I hope it sends you a link or something.
I think it like
Well, I
saves
think-
it to your YouTube channel, and then you just copy that.
It's just, yeah, once we're done, once I stop, then it shows how long and all that. I'm pretty sure. Okay, so I figured out what the degrees of freedom are. In that the student's T probabilities applet,
Mm-hmm.
that is where you have to put in the degrees of freedom.
Okay.
Because that depends on that tells you your arc. That's why anything greater than 30 is the same as if it's just a normal. Does that make sense?
This is the normal distribution.
Yeah. That's why they say that anything over 30 is fine.
Oh, okay.
All right.
Okay.
All right. So do we want to go over? We're on number 3.
Yeah.
Okay. So in this lesson, we have assumed the population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed?
Sigma's unknown.
Yeah. I mean,
Yeah. Now it's unknown, right?
yeah.
Yeah.
Okay, you ready to go on?
Yeah.
For the next few questions, let the null and alternative hypothesis be H of O is the mean equals 8, and the alternative is the mean is greater than 8. And theta is not known, so she collects a sample size of 9. Her mean, the sample mean is 11, and her standard deviation is 6. So is theta known? Well, just a second ago it says no. Don't know why they ask us that so many times, but
Good questions.
so I use the formula to find t, the x bar minus mu over the s divided by the square root of n.
I did the same thing.
So did I.
I did too.
1.5.
0.5.
Wait, negative 1.5?
No, 1.
No, just 1.5.
Yeah. 1.5.
Because the
Wait.
mean, the
Wait.
x bar is 11. The mean is 8. So it'll be 11 minus 8 divided by 6 is your standard deviation divided by the square root of 9, which is 3. So 6 over 3 equals 2. So it'd be 3 over 2 or 1.5.
Oh,
Right.
I accidentally put a negative in there. Okay, that makes sense. When I hit equals in Excel, I must have hit minus also.
There you
Okay, there we go. Okay, I can read the next one. Use the following values which are pulled from the data file body temp for the next 5 questions. Copy and paste them into your software, which doesn't work. I had to type them all in by
go.
hand.
Me too.
What I do is I went back to the original Excel file for body temp,
Yeah.
and then you just count down how many, then copy that and paste it in.
There you go.
Use the null hypothesis. Mu equals 98.6. Alternative hypothesis, mu is less than 98.6. And level of significance, 0.05. So what is the sample mean? I mean, it gives it to you there, right?
No.
In the thing, it's not 98.211.
Yeah,
I
that's,
got 98.220.
Yeah, I had 98.22.
Yeah.
How?
In the quantitative inference procedure, if you plug those numbers in, that's where I got the 98.22.
Yeah, I did that too, and I got. Hold on, let me see if I put the numbers in wrong
Yeah,
now.
check your typing.
98.4, 98.9. Oh. Hmm. Sorry, guys.
That's
You're good.
okay.
96.9. Yeah, it looks like I was putting them in wrong. I'm just fixing them now. Gosh, you miss like one number and it messes everything up.
Yeah.
Seven and 98.2. Okay, 98.220.
yeah,
Yep.
Cool. And it's 3 decimal places, but it ends in a 0, so 98.
yes.
Yep.
Okay. And then the S is just given in this in this thing too.
Yep.
Yeah.
Yep.
Point
0.922.
Yep.
And then did you just use like T that was given there also?
Yes.
Okay. Well,
But
let's
you
see.
got to make sure you've got everything in right. You got to have the standard or the
Confidence
null
level.
hypothesis and all that kind of stuff in there correctly.
Oh, right.
Because that changes, when you change those, it changes your P value for sure. I don't know about the T.
Yeah. Oh, yeah, it does change the T. It just changed a lot. Okay. So 98.6 less than. Okay, so did you get a negative for your T
Yep.
score?
Yes.
Negative 1.843.
Yep.
Yep.
P value 0.040.
No. 0.041.
I had 0.040
Yep, me too.
and it counted it right.
You already submitted?
Yeah.
I noticed something on the preparation assignment too, where they had rounded wrong on the answer.
I found one that was wrong. Yes, I agree. There was one that was
Yeah.
rounded and I couldn't figure it out. It was
And that
rounded wrong.
assumed that they rounded up when they weren't supposed to on the answer key or something.
Yeah.
Because I couldn't figure it out. Okay. So if P is lower than the null hypothesis, which it is, then reject the null hypothesis?
Yep.
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 Have all of you already gone through and done the whole quiz?
I haven't done 15 and 16 yet.
Okay.
So you're good. We'll just work through it.
Okay, sorry guys.
That's okay.
Not a big deal. We're just
I just
Over
feel
here.
bad because you're all stuck at work, like trying to go home after you do the homework.
I'm at work till 6:30 tomorrow morning, so it doesn't matter to me.
Don't worry about me. I'm fine. I have another quiz to do after this one.
Okay. So use the following values, which were pulled from the data file Baby Boom for the next 6 questions. These values are the wait time in minutes between births at a hospital. Copy and paste them into, what is SPSS?
It's just the same one we're using.
Yeah.
It's
Okay.
just the same one we've used. I think SPSS is the Apple version of Excel.
Yeah, it's some other version. Yeah.
Oh, okay. I
I
was
don't think
hoping it wasn't like another Excel thing. Okay, so I'm putting these numbers in. So the hospital claims that the average time between birth is 40 minutes and plans its resource allocation based on its claim. So the null hypothesis is 40. And you want to test their claim, and the type of test is not equal to. Okay. So did you guys get 0.871 for the p-value?
No.
Oh my gosh, did I put it in wrong again?
You need to adjust your confidence level and null hypothesis and type of test.
Oh. Where does it say what the confidence level is?
It's 0.01 is the level of significance, so it would be 0.99, right?
Oh, it's just the difference.
Yep.
I had
Okay.
0.95. Why have I got that and you don't?
Because in the next part of this question,
Oh, down farther.
Okay.
because your p-value should have been 0.995.
Right.
Where does it say that? Why am I missing that? Where does it say that?
Say what?
Where's the
Which?
p-value? Okay. Oh, sorry. Yeah, the p-value. Yeah. It's 0.995. Sorry.
Wait,
I meant the
but
confidence level. I was trying to figure out the confidence level. Okay.
what did you put in for the confidence level?
0.99.
Right.
Okay.
I think that only affects the interval anyways.
Gosh.
No, it changes the. I'm pretty sure it changes the p-value.
0.995. All right.
You're right. It doesn't.
No.
It's the type of test that changes the p-value.
I just had put in, I missed a number again.
You're good.
Okay, so 0.995 and then number 12, you reject it because the p-value is lower than.
No, it's greater than, so you failed to reject.
No, reject.
Wait,
The p-value is 0.995, which is greater than 0.01. So thus,
oh, you're right.
failed to reject the null hypothesis.
Okay. Awesome. You decide to try another alternative hypothesis. This time you use mu is less than 40 and keep the same level of significance. Did the p-value increase or decrease? So if you change it, it decreases.
Yep, but it's not enough to change. You still failed to reject. That's what I got.
Yes, because it's 0.5 and we need 0.05. or
I
0.01.
actually need 0.01.
Yeah.
Less than 0.01. So, John, Scott, you guys
Yeah.
with us on that?
Yeah.
Let's see
Right.
what I had. Yeah, I can't. I'm trying to recreate it, and I'm having trouble recreating it now. It's like get it right the first time. Anyways,
You're good.
I wish the tests were like group tests because like, talking out loud with you guys makes it make sense. But then when I do it on my own, I'm like, what is going on?
I'm the same way. I felt like I was pretty confident with the group, but when it came to exam, man, it was like everything we had talked about went out my brain, and I just stuck here. So.
Yeah.
I figured out how small I could write on one piece of paper, and it really helped.
Well, I'm gonna have to do better at that.
I wrote really small as well.
Yeah, I had a lot of notes. It really helped.
Did it ever say how big the paper had to be?
Good point.
Bye, poster board.
There you go. So
Maybe you should
Now-
scratch that from the video.
the question I have for this one, does the confidence interval change? And I'm checking it out on my own. No, it doesn't. So this one, the only thing you have to change now then is the confidence level from 0.99 to 0.95, right? For 15.
But also, don't you have to change it from less than to not equal to on the type of test?
It doesn't change the confidence interval.
Oh,
That's what it changes the p-value, but it doesn't change the confidence interval.
so it wouldn't matter regardless.
I would change it just to be safe, though.
Yeah.
Yeah, it does change. It didn't change the confidence level, but I would make sure everything was right in my spreadsheet.
Yep.
So it's 23.499.
Yep.
That's what I got.
Okay, and then the upper limit is 56.597.
Yep.
Yep.
Okay. Submit.
100%.
Awesome. Same.
You guys did good work here.
Couldn't have done it without you guys.
So I'm still trying to figure that test problem out from before.
Okay, so what were you don't give me exactly, but just make up something. What were you given? You were given
So
what?
you're given a bunch of rates of return, and they are numbers from here. Let me tell you. So they're as high as 12 and as low as -15.
Okay. And you're
And
trying
so-
to get what the test statistic is? Is that what it was? Or the margin of error?
The margin of error.
Okay.
And so I have the just by highlighting it, Excel gives you the average. So I know what the mean is. It's negative 1.107. But so to find the margin of error, the point, and this is where I'm struggling, is to find the margin of error. It is the t with the asterisk, right? Times the standard deviation divided by the square root of the number.
Yep.
Well, there's 39 in the sample.
But
So,
do you have the sample group standard deviation? Because you can, if you put that in the one for the t, it'll give you, if you put those numbers, the
right.
numbers are
Here,
given.
give me just a second, I'll do that. Because, like I say, I don't know what the answer is, and I don't.
Yeah.
This isn't going to tell me what the answer is.
It will after the test, after Saturday.
Yeah. It will tell you after Saturday what
I think
those
so. I think that's what I read.
Is it possible you just weren't following like the right order of operations?
Well, see, that's the thing is I plugged it in right here. So hold on, let me.
Because Excel doesn't always follow it.
Right. So the confidence interval, 95%. So, and the null hypothesis on this one, I don't need the null hypothesis. So the mean is negative, the sample size is 39, and the standard deviation it says is 6.
Okay. And it should have your t-score there too, right?
Well, that's the thing that I'm not. It's saying negative 42.788. But that can't be right because this has to be. That's where I'm confused, is I don't know. So if I use that student's t probabilities display curve for this question, it's saying 39 months sample. So I'm supposed to construct a 95% confidence interval for the true mean. So first I got to find. So using that formula, my confidence interval, it says, is negative 3.052 to 0.838. And I got those two answers are correct. So I don't know, like I said, I don't know where to come up with the margin of error from. Hold on.
The margin of error is t times
TA.
s divided by square root of n. If you got to get the right t-score.
Right.
Which if you plug, if you plug that into the one sample t-test for means, if you put all your
Right.
your samples in, shouldn't it'll give you the t-score, right?
I don't know. That's what I'm trying to figure out.
It does. Under variable one in like D21, it gives you the t-score, doesn't it?
So, hold on. Sorry, I've got so many screens open, I'm getting lost. Okay, so what is this standard error of the mean? What does that mean on this quantitative inference procedure?
Mean is the standard deviation divided by the square root of the sample size.
That's the standard error.
Oh yeah, that's the standard error right there. You don't even have to do math. It's right there.
Mm-hmm.
So that's the margin of error. But that doesn't add up.
Well, the way we could make sure is you could take the mean and subtract that number and see if you get your confidence level, add and subtract.
Right. So the mean. Sorry. Thanks for hanging with me for a second.
No.
1.1.
Boy, I thought I had this down. Now I'm totally confused. Thanks.
That's not working.
Yeah.
Because it should be according to the confidence interval. Hold on, maybe. Sorry.
Did you guys do the homework yet for this assignment?
Yeah.
Because I think there's a question on the homework that's a lot like what you're asking. There's one for about the double stuff Oreos. It says find the
And I did
interpret a 90% confidence interval after calculating the margin of error for the true mean weight of the filling of double stuff Oreo cookies. Is that the same kind of question?
Yep.
Well, we know the answer on those, so let's just do that one together, and then it should work for the quiz, right?
Yeah.
So there. Let's try this. Let's get the Oreo cookies going.
Real cookies.
Hey, you want me to share my screen and you guys can walk me, make sure I'm doing this right? Does that sound okay?
Absolutely.
Okay, let's see if I remember how to do this. Where is it? Which button is it? Share screen.
All right, yeah.
Okay, so did it work?
Yeah.
Okay, so let's go up here. Let's open up this one, right? We need that, right?
Mm-hmm.
Okay, and we go here to Oreo cookies. Okay, and we're going to start off with traditional, I think, is the first question, right?
You're
Yeah.
right.
Okay, so we go. Okay. 50 samples each cookie. I got 50 in there. Oh, I've only got 49. I didn't do it right. Dang it. What did I miss? I hate it when I do that. Oh, when did I miss? Did I miss the 2.9 at the top? Is that what I missed?
There
No,
is
it's
only
four-
49. Because the
It's only
top,
49.
yeah, there's only 49 there.
Oh, well, it says about 50. I did the same thing when I did the homework. Okay, I remember. All right.
Stupid word about.
Yeah, it says about 50. Okay. In grams, other stuff. Okay, so interpret 90% confidence. So we're going to go 0.9 right here, right?
Yep.
Got null hypothesis is that it's going to be yeah, what was the null hypothesis? What was that again? We have to get that in there?
Let's see.
And they're going to have to calculate the margin of error for the true meaning. Wait. Oh, maybe you don't do it in this. Okay, so how did I do it last time? Okay, so if we go. You guys are supposed to walk me through this. I was supposed to just do it. So if you have any suggestions, 0.374.
You're good.
374. And my n is 49 square root 7, right? So
Hill. Yes. I got it. Okay, bye.
yeah, there's no way. My t-score is wrong. Why is my t-score wrong? How do we fix this thing?
You might need to change that.
Yeah.
Yeah. I don't remember how I did it. I got it right.
What does it say? Oh, I gotta open this. Hold on.
There's a group of students.
Hit enter where you've got that 10. Oh, that didn't change it.
How did I do it? Of course, I didn't write my work down. That would have been smart.
Yeah.
Oh, well.
I was just trying to look at the homework and try and figure out if it gave us the.
Oh, there it is right there. It gave us the mark. That's the right answer right there. 0.053. That's it right there. That's the answer. Yeah, these answers are right, aren't they?
Yeah.
They are. I'm making it way too hard. In fact, this probably.
No, it's not.
I'm not there.
It's not right.
You don't think it's right?
Well, I guess it would be double that, right? Because when I did it on that one that I'm struggling with, it doesn't It doesn't add up. Because it shows point. Anyway.
Let's check. Let's get the answer sheet up, and it'll tell us. Okay, that's number 13, right?
Yeah, but it doesn't. It tells us to calculate the margin of error, but it doesn't. Actually, all it asks for is the 2.808 and 2.988.
Well, if we take the mean, which is 2.898, and we subtract 0.053, that doesn't match up. Stupid math.
All right, bye. Sorry.
Oh, well, that was helpful.
So here's what I'm thinking. What if you just took the difference between your confidence interval, divided it by 2?
Well, what are you trying to figure out?
So in the question on the quiz, it's asking for the margin of error. So if you took the
difference.
the average, well, yeah, the difference between them. If that would give you, and then divided it by 2. What the? Wait a second. No, I know what you do. You take your high and your low and subtract it from the mean.
Yeah, that would probably give you, that would give you your margin of error. That would. Wouldn't it?
Yeah.
Actually, you'd add it to your high and your low and subtract it from the mean. Yeah, it seems like you should add one of them.
Right.
Subtract one and add one.
Subtract. But it just seems really complicated.
What was that answer again on that one?
On 13,
Yeah.
it's 2.808 and 2.988.
Confidence interval. Okay.
So the center would be your mean, and then your margin of error would be one of those, right? Because you add it to one and subtract it from the other. Gives you your...
Yeah, it does equal the mean when you do that. If you add the two confidence levels together and divide by 2, it gives you the mean, obviously. It's
Yeah. Okay, thanks, guys.
Thanks for what?
Well, when you go to do that question, if you come up with a better idea, let me know on Tuesday. But working through it now, that's the only way I can come up with it, is to subtract the mean or add it to the mean plus, one of the intervals. And that'll give you the margin of error. So I would like to know the T asterisk scores. It'd make it a whole lot easier.
Wait, the margin of error is just the standard deviation divided by the square root of the sample size times 2.
Why would it be times 2?
Or, I mean, what's the confidence interval?
Exactly. That's exactly what I want to know.
Oh, I'm caught up now.
Because in the last homework we did, it gave us that little chart that showed us for each one, but I think the reason it doesn't is because it depends on your sample size. Right? Because that's why you got to know that thing of freedom, whatever that is. The
Well, does it give you a confidence level? I don't even have it pulled up. Does it give you a confidence level in the problem?
yeah, it's 95. Yeah, it's a 95% confidence level.
Okay, so it's going to be 1.96 times the population standard deviation divided by the square root of the sample
But
size.
1.96 only applies to last week where we knew the theta.
Oh my gosh, you're right. This is confusing.
There's too many weeks in my head.
So here's the. Are you still sharing, Scott, on your screen?
I've turned it off. I don't think I am.
Here, let me share mine and I'll show you what I'm looking at. So it tells me that there are 39 people in this one,
Mhm.
and it's a 95% confidence level. So would this be the T asterisk score, this 0.063?
Wouldn't the highlighted be in the center rather than the edges?
I don't know. That's what I'm asking.
I think that's the confidence interval right there. I think it's inside, isn't it?
So then it would be 2.024.
Yeah.
Let me do the math real quick on that. So then it would be 4 times standard deviation of 6 divided by the square root of 39. So if I'm messing you up, I'm sorry, but yep, that's it. That's how you do it.
Okay, so you get the T-score off of the applet.
Yeah, this applet right here.
Okay, you put in the confidence level, make sure your degree of freedom is correct, and then it's highlighted in the center to get your T-score.
So that's why we need the degrees of freedom. Because
Right.
if you change that, it didn't change it.
Yeah, because once it goes over 30, it gets more
Oh,
like a
so
normal.
let's try 3. Oh,
Yeah.
but
So
still,
change.
still
Did
the
it change? Did it change that number down there? I can't tell. It did, right?
0.024.
Number just change the shape of the distribution.
Okay.
Oh wait, hold on.
Did it
That
change?
area
Did it
is
change the
different.
T-score?
Yeah, it did change it. See, I had to change the area again.
Oh, because it didn't change the T-score, it changed the area because it shrunk.
Yeah. So, yep.
Okay.
So that's why we need to know the degrees of freedom.
Okay. To use the applet properly. Okay.
Yep. So,
Right.
hang on to this one. This one's
So if you know your probability, you know your standard deviation, you know your N, you go to that, get the T-score, do your math, and that should be the margin of error.
yep.
Okay. All right.
Yep,
Cool.
because like I said, like the way I figured it out when we were talking how to find it was just take the difference, but then to use that formula, just, I don't know, I'm a math guy, so at least I thought I was. Okay, guys, well, sorry it's taken an hour, but I appreciate your help.
That's okay. It helped me figure out some stuff I wasn't quite getting right.
I think if we hadn't gone over that, none of us would have gotten it right anyways. So.
I would have missed that completely.
Yeah. So good.
Thanks, guys.
All right, thanks. We'll see you on Tuesday.
Okay,
Thanks.
bye.
Uh,